Hey math kids, today we're going to talk about optimization, and yeah, let's just jump right in. So we want to make a rectangular cake dish, and the way we're going to do this is we have a piece of metal and we are cutting out the corners and then folding it up. So we're going to fold along these dotted lines and we're going to cut out those squares in the corners, fold them up, and let's see, so the entire thing here is 40 centimeters. The entire thing here is 25 centimeters. And we want to know how big those squares need to be to give us the maximum volume. Okay, so what we're going to do first, we're going to call the length of these squares x. So we have that all over. Okay. And then volume of a rectangular prism is just length times width times height. And so the length right from here to here is going to be 40 minus 2x. Because if we went all the way across, it's 40, but then we take out an x and take out another x. Similar thinking, the width is going to be 25 minus 2x. And then our height is just going to be one of these squares because when we fold it up, and so our height is x. Okay, so our function is going to be length times width times height. Okay, so let's just multiply that out. So if we do 40 times that, we get 1,000. Then if we do that times that, we get negative 80x, negative 50x, positive 4x squared. And we're still timesing that by x. So we're just going to raise all the powers of x on this. If I combine those, I'm going to get negative 130x, and then timesing it by the x gives us an x squared, and then plus 4x cubed. This will be measured in centimeters cubed, and this is our volume. Okay, now a couple things we need to note is the maximum that our x could be would be half of 25. So half of 25 is 12.5, and the smallest it could be is 0. So we're going to be in between 0 and 12.5. The reason why is if we try to get bigger, like if we do 13, we're going to have 13 and 13, and that overlaps to make 26. So it doesn't make sense. So you take the smallest side and you cut it in half, is how you find this. Okay. Now, because we want to maximize this, remember, like if we were to graph this, it's a third degree function, so it's going to look possibly something like that. And we want to find this point right here. Now we know from previous lessons that we just find the derivative whenever we get these peaks or valleys. And then we'll have to determine which one's actually a maximum or a minimum. So we take the derivative of this. So we get 1,000 minus, bring down the 2, so 260x. Bring down that, we get 12x squared. So that's our derivative. We want to set that equal to 0. And let's see, we can take out a 4 from everything. So we get 250 minus 65x plus 3x squared is equal to 0. And then if I reorder this, 3x squared minus 65x plus 250. And that's multiplied by 4. Now we can use our quadratic methods to solve this for x. You can factor it, or you can plug it into the quadratic formula. Either way, I'm not going to go through that right now. Maybe I will. Yeah, let's do a refresher. Okay, so let's do factoring. So I do 3 times 250, so that gives me 750. That's going to have a lot of factors. So 1, 750, 2, here, I'm going to use a calculator. Oops. Okay, so calculator. Having a hard time, sorry guys. There we go. Okay, so we're going to say 750 divided by 2, so we got 375. 750 divided by 3 is 250. 750 divided by 4 doesn't work. 750 divided by 5 is 150. Okay, 6 should work as well. $125. All right, 750 divided by 7. Don't think that'll work. 750 divided by 8. 750 divided by 9. 10 won't work. 11 divided by 12. Let's see, we getting close? No. Let's try 15. So 15 and 50. And I think that one's going to work, because if we make both those negative, then they add up to 65. We do our box. For box method, we get 3x squared. We get 250, and then we get negative 15x and negative 50x. Okay, factor out, we get 3x. Factor out, we get 50. Factor out this way, we just get x. And factor out this way, we get 5. Now, because there's a diagonal of negatives, we actually want to put negatives on both of those. And then we get 3x minus 50 and x minus 5. We still have our 4 from right here. And now we can set these equal to 0. Okay, so if we solve this one, we get 3x minus 50 equals 0. And we get x minus 5 equals 0. The 4 is not going to do anything, so we just kind of ignore it. So we add 50. 3x equals 50. And we divide by 3. So x equals 50 over 3. And then we add 5, x equals 5. Okay. So if we do 50 divided by 3, that's 16.666. That's outside of this range that we have right here, or our domain. And so we're going to throw that out. And so x equals 5 is the answer to optimize this situation. So what that means, if we make these 5 by 5 squares, the volume of the cake pan will be maxed out. Okay, so we're going to